is working as associate professor in the Department of Electrical Engineering at Indian Institute of Technology, Patna. He received the PhD degree in Electronics and Electrical Communication Engineering from IIT Kharagpur in 2007. From 2008 to 9, he was a postdoctoral research fellow with the Department of Computer Science, University of Missouri, Columbia, USA, where he worked on intelligent video surveillance systems. During May to July 2017, he worked as DAT Fellow in Technical University Berlin, where he worked on EEG signal analysis using machine learning and deep learning. He has authored a book titled Intelligent Video Surveillance Systems, an Algorithmic Approach, CRC Press, Taylor and Francis Group, 2018. He served as a head Department of Electrical Engineering, IIT Patna in 2013 for 1 year and head of the Center for Advanced Systems Engineering, IIT Patna during 2014 to 16 for 2 years. He served as professor in charge, National Knowledge Network of IIT Patna during August 2017 to September 2019. He has successfully completed research and development project sponsored by the Government of India as principal scientific advisor on abnormal human activity recognition. So that is the brief biodata of a resource person. I request all the participants to attend the session attentively and ask the questions at the end of the session. You can type in the chat box or you can ask directly. It is up to your convenience. And a feedback form will be shared just before the end of the session, which is to be filled by all the participants. Attendance will be granted only if the feedback form is submitted by the participant. So keeping all this in mind, now I give the time to Dr. Mahesh Kumar H. Kolekar. Sir, please take your time. Thank you. Video. Video. Sound now, system the sound. Shall we tell him? Unmute করে দিব না অডিবল আনমিউট করে দিবে আমি Excuse me sir, your voice is not audible. You are audible question देगा तो on it is it it's audible ये वाला problem है
monitoring. Okay. So for any traffic management system, we have these blocks: data collection, data transmission to the center, data analysis, then data conversion, and again data transmission to the user. By using different sensors, cameras, or GPS tracker, we collect the information at the traffic management center through those sensors. Sensors can you communicate to each other or communicate to the center. So all these aspects are nowadays people are involving in the traffic management. And since traffic data is a video data, sometimes sensor data also, and image data also, so they take a lot of memory also. So we require a lot of processing techniques actually at the center. And
Sir,
quickly
excuse,
we want to extract some useful information from that data.
excuse me, sir. Is it possible to lower the mic a little bit? We're getting some disturbance.
Okay,
Please
just
lower the mic a little bit. Your mic.
okay, just
Maybe put it a little lower.
now is okay.
It's okay.
Hello.
Yeah.
Okay. Uh, क्या हुआ?
Hey, kalau postur dia ini.
Okay. So today we are going to discuss various deep learning techniques used to extract the information from that data.
Mic is too close.
And previously people have used machine learning techniques also, but since we get a lot of traffic data, so training is very good, and deep learning can be used successfully. So let us see the different features of any transportation system. Hello.
Hello.
Hi. Yes.
Sir, please you adjust your mic.
I have.
Lower, below.
Just you lower your mic. Little.
Okay. Just wait.
Below.
Now it's okay.
Yeah, below the chin.
Okay. Okay. हाँ
Yes, yes.
Yes, adjust.
Okay. Okay. हाँ ठीक है. Now it's okay.
Yes, sir. Perfect.
Okay. Just wait.
सर थोड़ा डिस्टेंस पे माइक रखो.
Okay. So these are the common features of operating intelligent transportation systems. One of them is internet of vehicles, then identifications, surveillance and safeties. You see a lot of surveillance cameras nowadays for traffic management at the various Golumbar, Chowk or roads actually. Then 5G connection we require for proper communication, and smart traffic signals. So all these components are very useful for intelligent transport system. So we can discuss some of the components also in this presentation. So Internet of Vehicles. So I have collected some information about Internet of Vehicles, that speed control, then security system, condition monitoring, then customer support, control center communication, okay, police emergency, then precision navigation, advanced diagnostics. So if we add all these things to the vehicle, then we will get a lot of safety and your pleasure also. That if there is an accident, then automatically your vehicle will send some signal to the police for emergency purpose. Then one vehicle can talk with another vehicle. So if vehicles of particular school or particular colleges are on the road, so they can also communicate with each other. Then condition monitoring of the vehicle can be done using some sensors. Speed control is one of the important aspect, so that also possible. So that's why we require a lot of IoT sensors and data processing devices for this purpose. So you can see smart traffic signal control systems. Okay, automatic number plate recognition. This is a very common application. Recognizing number plate is easy, but when vehicle is on the road, actually we get a different hues. So invariant number plate recognition is one of the requirement. Okay, and another thing is a vehicle tracking. Generally for police or person, this is required. If somebody has done the accident and vehicle is now away from the location, vehicle has moved, so people can track that vehicle actually through the aerial cameras or aerial videos, and then we can punish that person actually who has committed the accident. So this is one of the common algorithm. So uh, whenever we capture any surveillance camera, video from surveillance camera, we get a lot of vehicles, not only single vehicle, you can have three, four, five vehicles in a single frame. Then we can put a blob around each vehicle, and then we can track, you can give ID to the vehicle, like a vehicle number 1, vehicle number 2, vehicle number 3, and then we can track each vehicles. How to detect the blob, that is also one of the important aspect. So if we take two successive frames, and if we take their difference, then remainder is the only moving pixels in the frame. So we will identify the homogeneous region of the moving pixels, and depending on their size, we can decide whether it is a vehicle or not, and then we can put a blob around it, and then we can track that blob. Can we estimate its position? So this is also another interesting question. Can we estimate the position of vehicle in the next frame? So people use so many techniques. One of them is a K. One, uh, so based on centered, one of them is a centered based tracking. So we can detect the center of the blob in the first frame, then same vehicle blob in the second frame, and then we will predict its location in the next frame. People use a Kalman filter kind of things for this type of problems. And okay, Mm, and in those videos, there are chances that new vehicle will also enter into the vehicle. So we can give a new ID to that vehicle. Sometimes few cameras actually vehicle is not visible, or because of occlusion, etc. So we should be able to give the same ID to that vehicle. So I'm talking about the cameras. Series of cameras are placed around both sides of the road, and each camera will have a communication with other camera, and in this way we can track the vehicle by using cameras. So lot of work is required in this area, research area. Speed detection, this is also another important requirement. So people do the speed detection using some sensors. They put a sensor, and if vehicle cross that sensor, then another sensor will be there. So by counting the duration and using the distance between those two sensors, one can predict the speed of the vehicle. And another thing, nowadays people use this camera-based speed detection also. Means there is a vehicle, as I mentioned, we can extract the blobs. So we can measure the movement using the location in the, or centered location in the frames. Camera number 1 location is at that center, for example, and camera number 3, that same vehicle is appearing at the top corner of the center. By using Euclidean distance, we can compute centered distance, and we can measure the speed of the vehicle. And if over speeding, then we can, means police can take action. So in this way, many things can be automated. And a country like India, there is a lot of traffic. One of the challenges actually vehicles are, because of the crowd, actually vehicles are getting occluded many times. So occlusion handling is also one of the crucial problem in CCTV camera based vehicle tracking approach. Okay, so just a glimpse of the developed countries and developed cities actually. So one of them is Singapore, where a smart state with a smart traffic. So there are all buses, taxis, trains are equipped with GPS tracker. So they can track actually if vehicle is standing at a particular location for a long time. Then from control room there can be a, um, it can be monitored, and proper action can be taken. So there, if there is accident actually, so immediately the monitoring control room will get information that because of the GPS tracker that buses and taxis have some accident, or other things. Okay, so people are using this nowadays. Actually, a driverless car is also one of the attraction. Even in Singapore, they have you place the system for metro stations. Actually, metro station to the main road, only for that small segment they are using the driverless vehicle. So there is a no stop, directly from the highway or road and state road to the metro station. So at least we can identify particular segments and we can place driverless vehicles to reduce the accident as well as reduce traffic and many other things. So so these are some of the attractive things about the smart traffic monitoring system. Next is a city like New York City. Also, they have also a lot of smart transportation system. So you can collect the information about this. The overall benefits of an ITS means intelligent transportation systems. One of them is a safety measure because everything we are monitoring actually. We have GPS, we have their video, and so if any vehicle is not if any vehicle is violating the rules, we can easily identify it and save the other vehicles actually. Okay, we can stop that vehicle. So that's why safety can be easily increased by using this ITS system. Economic values also, we can reduce money also, since as I mentioned, driverless car for connecting road to the station, metro station. So if we implement this at a bigger level in any country, then actually value of the transport system will reduce. Then environmental awareness. All these vehicles are actually uh, follow all norms actually. Uh, so all those things can be monitored easily by using electronic devices. So this is about the ITS system. What is the need of this smart traffic management system? This will reduce the traffic jams and accidents because everybody is now following the rule and proper actions are also taken because of the smart systems. Immediate clearance of the emergency vehicles. If any vehicle is identified um, in square, then like an ambulance or police vehicle, then a traffic control system actually, they will be given a priority. There will be some separate arrangements or separate lane. So in this way we can clear. Another thing, actually this regular traffic is not predictable. Sometimes if there's any large traffic, one of the lane, so we can give some priority to those lanes by using the information, by using the CCTV camera footage, by using the ultrasonic or other sensors which are laid on the road actually. So by collecting those informations, immediate clearance can be performed. So facilitating safer and shorter commute times. Even these devices has a like we can send the information about the uh, forthcoming road also, means which the way the vehicle should follow. Like a Google Map, we know the traffic in advance. So same thing actually can be done easily, and vehicle itself will take a decision. Uh, this will be one of the important features for driverless car also. So reducing congestion, energy consumption at intersections, then offering significant productivity benefits with real-time monitoring of a crucial infrastructure, reducing operating costs with efficient traffic management system, ensuring compliance with the regulation for reducing the carbon footprints. Also, we can reduce the pollution actually. Those uh, so we'll check actually carbon emission actually from the vehicles. So saving billion of gallons of fuel wasted every year in because of the traffic jam, because of the accidents and wrong traffic management. So all these things can be addressed with these smart traffic management. We can track also important vehicles. If vehicle is lost, if there is a theft of vehicle also, stolen vehicle can be recovered easily. If we know the vehicle actually, particular vehicle was at location A, and somebody is reporting about the stolen vehicle after 1 hour, so we can predict actually where this vehicle will be after 1 hour. So that range, that area can be tracked actually, and all vehicles can be checked, and we can easily identify the stolen vehicles. So these are some of the advantages of smart traffic management system. So Our main focus of this today's presentation is a deep learning. So let us talk about something about deep learning. So deep learning is a subset of the machine learning, and machine learning is a subset of the artificial intelligence. Uh, okay. So deep learning attempts to draw similar conclusion as human would be continually analyzing data with a given logical structure. This AI, artificial intelligence, actually, this concept came from uh, how the functioning of the brain, how brain function. So same thing people try to mimic actually, and that's why the AI. Machine learning, actually, we are extracting the features and then classifying. But deep learning, there is no need to extract the feature also. Uh, but another limitation of deep learning is a requirement of large data for training purpose. Okay, so uh, uh, main this deep learning develops just because of the convolution operation. Okay, so this convolution operation, if we apply to the image also, so we can have various sizes of the filters or various types of the filters. If we apply on the image, we'll get a different results or different features. So features are extracted automatically. That is the beauty of the deep learning. So we'll discuss this one by one. Okay, a long back, actually, up to 2012, machine learning was popular. Deep learning becomes popular after 2012, just because of the introduction of the ImageNet database, which contains millions of images, actually 40 million images and 1,000 classes. And so they created the platform actually to check the results. So worldwide, people tested the results on this ImageNet dataset, and because of the various data learning challenges, architecture models, they conducted challenges every year in the beginning, at least 2013, 14, 15, and there was a development in the models, means large number of layers in the model, and different activation functions and other things also developed over the time. So deep learning is nowadays very popular. So if you want to apply the deep learning, one of the main requirements is a large data set. And fortunately, our application, traffic video monitoring, it collects large data. Large data is collected actually. In fact, we have to destroy the data, delete the data, because we don't have such a storage devices. And there's a delete policy also at the traffic monitoring centers. They delete data, means like after, for normal security systems, people delete the data after 30 days actually, and again starts rewriting on the hard disk. Okay. So while deleting also, we can remove the data which is not important first, and then delete the other data. So all these things are there. So since the data is big, people are attracted to use deep learning, and machine learning works better with the small data also if we extract proper features. Then dependency of hardware. So why this deep learning was not popular before 2012 or even before that? One of the reason was the computing devices actually. So this high computing machines was not there in the beginning, because if we use a large data, we require large processing time. So to reduce that time, we have to do some parallel computing or cluster computation we have to use. So for that purpose, people use a very good hardware. Nowadays, such hardware is available. So that's why deep learning is a good choice. Feature engineering, understanding features needed to present the data in machine learning. So machine learning, we have to extract the features object for classification purpose. And the performance of this machine learning classifier is based on the features. So if we select a proper feature, then your classification performance is good. If you select a wrong features or less important features, then this will affect the classification performance. So that case is not in the deep learning. So deep learning, we extract the features automatically. Automatically means by using the convolution operation. Those who are in electrical engineering or electronics engineering, they might have studied convolution operation in signal systems. So same operation, is used here to extract the features. Okay. Time required for execution is also very high in deep learning because of large data and large number of filters, large number of layers. If we use a large data, large number of filters, then we will have a very good performance actually. So that is the limitation of deep learning. And most of the time it is difficult actually why we got the best results actually. Okay, so that's why it's very difficult to interpret the results. Okay, most of the architecture like VGG 16 exception or many other deep learning architectures which are very popular for object classification purpose. So there actually um, up to certain extent we can interpret the results, but it's very difficult to interpret everything because most of time people have used these number of layers, then the filters for those layers, all those things are based on some domain knowledge they have used. So, but another thing in the coming years, actually, this area is growing. Actually, people wanted to investigate what is happening inside the deep learning model. People don't want to keep it as a complete black box, and that's why um, this area is also growing. Okay, it is called as this new area is called as a explainable AI, explainable artificial intelligence, or explainable deep learning model. Okay, so. So this neural network idea came from the human neuron actually. So neuron has a large number of dendrites to collect the information from the previous neuron or other neurons. So here these X1, X2, XM, these are the dendrites or uh, or information collecting sensors you can say, or okay. So these are the X1, X2, XM. These are the input neurons to this, and every dendrite has some weight. So x1 into w1, so that value will be collected here at the cell of the neuron, and the response from all these input neurons will be collected, and sum will be performed. And if it is greater than some threshold or some activation function, here some activation function is shown, then this neuron will fire, or then this neuron will send information to the next. So we will get the yes output. If this is below threshold, then output is 0. So this is the simple idea of a neuron. Okay, it's called as a perceptron. So this figure, so this is the neuron actually in human brain. So it has a large number of dendrites. These dendrites collect information. Information means actually some potential. They collect some potential, and at the center actually cell body, all these potentials will be summed actually. Okay. So total potential. If this total potential is greater than some value, then the neuron will fire. This we are talking about the neuron in our brain, natural neuron. Okay. And if this neuron is fired, then that potential actually will travel. This voltage will travel through this. Okay, and this yellow color is called as a myelin. Actually, this is a cover, acts as an insulator to avoid the loss of the signal. And this last this neuron, this is called as a synapse. This is a single neuron actually, and these are the dendrites. So large input nodes and large number of output nodes. These output nodes will again connect to the dendrites actually. If there is a potential, then same potential will be transferred to the next neuron, and in this way, there will be communication, and links will be happen. So in our brain, millions of neurons are there, and trillions of their connections actually. Okay. Uh, so even to study the human brain also, it's a difficult means. Our brain also acts as like a difficult to interpret also means that neuron path and other things. But people now nowadays using a lot of uh, statistics actually to detect some diseases using this. Okay, but this neuron we have mimicked, and just now I explained in the previous slide also that this is the nodes. This is the bias. There, these are the weights, and SI is equal to this weight into the input. This is above some threshold. So this is the activation function. This actually we have to decide which we should use activation function for this purpose. Okay. So if f of x equal to 1, meaning is this neuron has fired and we'll get a 1 at the output. Otherwise, we'll get 0. We can say the neuron has not fired. This potential generated here or received at the input are less. Okay. So multi-layer perceptron. So this is the actually case in our brain also and in deep learning also. So we are not using a single neuron, we are using a many neurons. So here you can see there are many neurons, 1, 2, up to n. And this input data is also given not only through the single neuron, it is given to the many neurons. So that's why and instead of using one layer actually, we have another layer also. So that's why it is called as hidden layers, and this is the output layer. These are the output nodes, and this we can use for a classification purpose. If it's a binary classifier or a two class problem, if this node is giving a more weight or more signal, and this is a class for cat actually, this is for dog, and if this is giving higher response, we'll say that input image is nothing but the image of cat. So in this way, people use this um, neural network for the classification purpose or segmentation purpose. So we are going to see that. So initially, actually, this artificial neural network was popular, and deep learning becomes popular later on after 2012. So what is the difference between artificial neural network and deep neural network? So both are same actually, but if you introduce more and more layers actually, that's why the word deep is used, and we'll call it as deep neural network. Okay. So there are various training algorithms like a feed forward or back propagation algorithm, adjustment of the weights. So here you can see these weights. So in our during the programming, we can give some weights actually, and we'll get some output. So this is called as a forward, forward input training actually. Otherwise, second case is you check the result here during training. If your model is saying its image is a image of cat, but since you are using the training, you know the type of class of the image. If it is a dog image, then our results are failed here. So we can find the loss here, and based on that we can update the weights actually, weights of the all previous ages. So this is possible, and it is called as a back propagation. Most of time people use a back propagation algorithm, means computing the loss and then updating the weights. Then again another image, again you update the weight. So in this way, weights will be updated, and um, so that's why more the training, better the weight updation and better the results. Okay. So these also I discussed. This is the list of different um, activation function. So this is the identity activity function. This is the binary step. Okay. So x is less than 0, then f of x equal to 0. So this is the binary step. Then this is a logistic function. Okay. Uh, ReLU is one of the popular function, a rectified linear unit. So from 0 to plus infinity it's regular, and 0 to minus infinity it's 0. So based on the input, based on the value actually, value of x, the activation function will have value 0 or x. Okay. So this is a widely used ReLU function. Then so these are other functions also. And people use a gradient descent algorithm also. So there are many algorithms for this optimization purpose. This back propagation I discussed. So now let us talk about the traffic monitoring. That is the topic of discussion today. So for traffic monitoring, which type of models are used actually? So uh, so here data from the few papers is presented. So you can see here in the paper published in 2017, car detection from low altitude UAV imagery with the fast RCNN. Okay. So they use a region proposal network, and that's why the name is RCNN. CNN is a convolutional neural network, and you can see the algorithm here. This is a training stage, so training video, training data set, and from that data actually they compute some propositional networks. Okay, so we are not going to those details. Okay, and and the model will be trained. Okay, so during the testing phase, again we will extract the image, and the same model will use, and we will get the detection results. So here, while training phase actually, if data is training is good actually, then detection or classification will also be better. Another is a RCNN model. Okay, okay. This yellow model is very popular even for traffic video monitoring. We have seen a lot of versions they use actually. Mainly this yellow was proposed for object detection purpose. Yellow means you only look once. Okay, so this model is very popular, and you can see the result actually. So there they are able to detect the truck, then person, car, traffic signal, traffic light. Okay, then bus. Okay, so many objects can be detected easily because this model is trained on the large number of classes actually, and some of them are vehicles. So people wanted to use this for vehicle purpose. Okay. Mm, another model. So we can refer these papers actually for more details, but just I have collected important papers from traffic video monitoring point of view and important models. So you can see here CenterNet. Uh, they've used their own data set. Here you can see the vehicle. CNN is a backbone. Why CNN is required? Because we want to extract the features automatically. So CNN will extract the features. There will be large number of CNN layers. So mainly um, there are various types of layers also actually. Then cascade corner pulling, then corner heat map they used, and you can see they able to extract the vehicle successfully. Another is the SSD MobileNet V2 network. Actually, this model was proposed initially. This MobileNet V2 one was there, then MobileNet V2. V2 means version 2 model. This they proposed just for um, uh, they wanted to use a smartphone or mobile as a device actually. So they use this MobileNet V2, and they use the transfer learning to fix the weights actually. Um, so I think you may be aware about the transfer learning. So transfer learning means that there is a uh, model which is trained on imaginary data set or any other data set. Same model we can use for some our data set. Like we have developed one model for traffic video monitoring, and I want to use same model for disease detection. Okay, disease detection. Then I can change some of the layers from that model actually trained model, and I will check the results, uh, and then I keep on training actually. Okay, that model. So that idea they use. It is called as a transfer learning. Okay. So somebody is interested, anybody is interested, we will discuss that transfer learning. But this transfer learning, uh, they use for mobile net weight updation, and net V2 is a low, mm, means requires a low competition. That's why this is a popular, and that's why it can be used on the edge devices or mobile phone. So they are used. Now let us discuss the work going on in my video surveillance lab at IIT Patna. So you can see here, we have done some work on vehicle classification and counting for traffic video monitoring. So you can see here, we have to select first video footage, and we are performing some masking. Our objective is to count the vehicles. So we have drawn some counter lines on the image, and we have created the blob around the moving vehicle, and we have classified those blobs using this yellow version 7 to classify into car, truck, and two-wheelers. And if count, okay, if it is detected, then if count is above some threshold, then we say that it's a heavy traffic. Otherwise, there is no traffic or no traffic congestion we can say. So you can see this footage we captured at the gate of IIT Patna, gate number 1, where we have installed the cameras. So you can see, to reduce the competition as well as to improve the accuracy, this unwanted block we permanently removed from the image. Actually, we know this is the only road, and camera is also fixed. So every time we are going to capture this much video, so we have this mask. Actually, this is called as a masking operation. And then we have plotted some lines. Actually, here there are 4-5 lines, total 6 lines we have drawn, and we will compute the centroid actually of this moving object. Before that, before entering into this lines actually, and if that crosses through all the 6 lines actually, every time we will check actually, and then we will count it. Okay, we will increase the count if it passed through the all 6 lines, then count will be increased. But now this is increasing the count of the vehicle, but we want to classify. Actually, we want to increase the count of car, count of bus, count of ambulance, count of two-wheeler. So for that vehicle classification purpose, we have used the yellow algorithm, and that's why we are getting these results here. We have displayed a counter also here. So in this way, we can count the number of vehicles coming from the gate number 1 of IIT Patna. I'm going to show that video, so you can see this vehicle. So car counter is 1 now. Truck counter is 0. A lot of construction is going inside our campus, so we have included this truck also, truck counter also. This is a motorcycle counter. 1 motorcycle is coming, so counter has increased. So in our case, actually, we are considering incoming and outgoing both vehicles, but it's not difficult to separate those things. So you can see motor vehicle passed, so counter has increased. Now this truck has entered. The counter has increased. Motorcycle also increased. Now also it will increase. Okay. So this is a real-time applications we developed for IIT Patna gate number 1 to count the vehicles. Even if we get this data also, we can plan proper traffic management. Since it's a institute gate, actually there is no crowd, but same model can be deployed at city, in the city actually, city squares. Okay. So we have done some data analysis, and these are our conclusion. So on which date there was a highest traffic, then which vehicles actually entering in the campus, means where number of cars are more or number of buses are more. Okay, so all that data during what time, 6 to 7 p.m. what time there is a rush actually. So that statistics also developed, and depending on these statistics, we deploy the security person at the gate. Okay, so during night time we have less number of security person there. Daytime also during morning time there will be more security persons. So we can take some measures by using this type of information. We got very good accuracy actually, accuracy of 94% accuracy. Okay. Another problem we handled for IIT Patna campus is a two-wheeler traffic rule violation, because in India also, or you'll find large number of two-wheelers. Okay, in our campus also we have large number of two-wheelers instead of four-wheelers. So we have planned to detect the two-wheeler violations. So what type of violations? Like no helmet, then triple riding. So these violations will targeted. And we have used very simple approach. We extract the frame from CCTV footage, then we region of interest detection, or we can put one blob around that moving vehicle. Here blob is there actually. This blue color is a blob. So such a blob will put across the moving that vehicle. So how can we put this blob? We can subtract two successive frames. We'll get some difference. So whenever there is a high difference, so we'll understand something is moving in that region. So we'll put one box around that object, and we'll track that object only. Okay, we'll process that object only. So we'll detect that object. So our yellow algorithm will detect only that extracted region, not the complete frame. And then that algorithm will say whether it is a vehicle, it's a two-wheeler, four-wheeler, bicycle, etc. Okay, and then we have use algorithm for this detection, helmet detection, and number of heads actually, persons for triple traveling. So in this way, we can use small traffic monitoring systems to improve the traffic congestion problem and other traffic issues. Another is this. This is about the yellow fee version 8 version. This is the latest version of the yellow algorithm. It's open source, so it's available on the internet. You can download and use. Um, you only look once actually that algorithm. So this is very popular for object detection. So same thing we use for our vehicle identification purpose. They have tested this algorithm on COCO data set actually. COCO 100. There are 100 classes. COCO 10, COCO 100. So you can use that. Another video I want to show that. This is at the entrance of a gate actually, outside road of the gate. Outside road actually. This is the IIT Patna entrance, and this is the road actually. Okay. So here the outside vehicles are also there. We have one camera facing to the roadside. So you can see here we have extracted the blobs. These are the blob vehicle coming from the IIT Patna. So here we are identifying the two-wheeler detection actually on real time. That is the beauty of this algorithm. You can see no helmet is there. The green means okay. Triple rider, so red color was there for a small amount of time. Here also red color, triple rider. Okay, so this is about the accuracy. Okay, so this is our initial work. We wanted to detect more number of classes, and we want to improve the accuracy also and increase our data sets. Since such a data set is not available online, we developed a data set, and we even tested on different yellow algorithm, because we are using yellow algorithm for most of our work. So we obtain this much accuracy. So accuracy is good for our data set is small, and test data set and training data set both are similar data set. Okay, so that is one of the reason. Another problem we identified is a pothole detection. You know, the roads actually, at least village side roads are not good. So something if we detect in advance that there will be hole, or there will be hole actually on the road, or there's a speed breaker. Speed breaker is coming. So before that, actually, we can give information to the driver, or automatically we can reduce the speed of the vehicle. So how this can be performed? So we want to you don't want to use so many sensors. By simply using surveillance camera, we can do this. So one such a small video I will just play. So this video we captured in our IIT Patna campus. You can see. So the person is riding the bicycle. So before reaching, he is coming to know that there are potholes. There are holes or speed breaker or damaged road actually. Okay. So you can see here. So this will help you actually to take a decision, okay, for driving. So this is also our initial work. We are working on this work further. And the algorithm is quite simple. We are using the cameras, then we are detecting the potholes. And okay. So these are the future prospects. So we want to work in this integrated with the autonomous vehicle, then enhanced visualization and user interface. Because we have now people are using express highways and many things. So visualization should be proper decision making. Driver should make the decision in advance. So we need some support system by using a lot of sensors, a lot of cameras. Okay, we can develop that cross city coordination, collaborative systems, AI enabled incident management. Okay, real time optimization. So many things are good, but they are not happening real time. So that is also one of the key requirement. And this is my book actually, Intelligent Video Surveillance System and Algorithmic Approach. In this book, a lot of video processing techniques are mentioned, like CCTV footage, how this can be, like this blob extraction is mentioned, anomaly detection is mentioned, human activity recognition, all those things are discussed there. Even this traffic monitoring probably is also discussed in the application chapter. So if required, you can go through this book also. These are our some of the key references related to this work only. So one paper we published in the Journal of Visual Communication and Image Representation. It's a very recent paper, and we have used adversarial autoencoder network for detecting anomalies in video sequence. Uh, okay. This is a paper more related to our work, today's presentation. This is advanced work actually, so I have not discussed much in the presentation. So here we have used vision transformer and gradient accumulation for vehicle re-identification. So what is meaning of the vehicle re-identification? So I want to track 4 vehicles. So I have given the IDs that vehicle 1, vehicle 2, vehicle number 3, vehicle number 4, and I am tracking them. Okay. Sometime occlusion is also coming. For some time, only 3 vehicles are visible. One vehicle is occluded behind the other vehicle, like bike can be occluded behind the bus or truck. Okay, for some time. So again, that vehicle appeared actually. Okay, again it is visible. Uh, so when it is visible, that time I should not consider this as a new vehicle. I should give same ID, like ID maybe ID number 3 or 4, whatever. So that's why it is called as a re-identification. So same vehicle re-identified, so same number is given. And after some time, okay, new vehicle has come, we will give a new ID to that vehicle. So this work is also very important. And so in this paper, that work is discussed. Another conference paper also you can refer, attention-based variational autoencoder for traffic video anomaly detection. So what are the video anomalies, like taking U-turn? Okay, if there is a one-way and person is taking U-turn, or no entry region the vehicle has entered, or um, uh, uh, lane is for coming incoming vehicles actually, and a person is using that lane for going actually. Okay, so direction of the vehicle. So many things are coming under the video traffic video anomaly. And if you are able to detect them automatically, then that will be a great help to the traffic police, and we can make the city really smart by using a smart traffic monitoring systems. So thank you. Any question?
Thank you, sir, for a nice talk.
Actually, I thought to give a overview of this topic actually. That's why I have not discussed deep learning and other things in detail actually. Okay. But if you have any question, you can ask me.
Yes, sir.
Is there any question in the chat box?
Chat box, any questions are there?
No. Ah,
Someone has raised the hand. Allow him.
please unmute me. You unmute me.
Hello.
Yes, kindly ask questions. Participants can ask questions, or you can also put in the chat box. I think some questions are there in the chat box. Just make the PDF. Open the chat box once.
They are asking to provide recording, so you provide them the recording.
Sir, somebody is asking, please provide the link of the book to download PDF. So if it is free access,
I think there is not a free access,
Yeah,
but I
it is
can
very difficult to get this this book. It's not
free.
an open book,
Yeah,
open
yeah.
access.
okay, somebody, Tejaswini is asking which processor you have used. If sir can kindly take the question.
Okay. Which for what purpose? Is for programming. Which,
Is the
are you asking
next
for the system used for deep learning programming?
It's already time.
Yes, yes. Yes, sir.
yes,
Excuse
yes.
me, sir. Am I audible?
Hi, you are audible, right? Yeah.
Sir, yes, sir. Sir, which processor actually have
360.
used? Means, can we do it in our own system, or you have used some specialized system?
Hi,
Which
you
CPU?
can better you can use a Google Colab actually. This works on Google Colab.
Okay.
We have a workstation in my lab also. So people, my students are using that workstation. But whatever results I have shown today, actually, they are not that much rigorous programmable results actually. Results which require rigorous programming. So we are using we are also using that Google Colab actually. Okay. And if you need a more memory or more speed, then you have to pay to the Google also. Then again, you can get a more. Uh, but Google Colab, free version of Google Colab is also enough for this programming.
Okay. Okay, okay, sir. Sir, then
So,
one tracking algorithm you have shown, ma'am.
all right.
Then what is the modification you did to that YOLO? Since you did not discuss about the your own model, just shown the result.
Hi, you know, for most of the results we discussed, I discussed result actually, not model.
Hmm. What is the modification in the model itself? Wanted to.
Actually, this yellow version, whatever we use, we have not modified that actually. Yellow version, right? For last problem, just a minute, I will go to the slides. That two-wheeler rule violation, there we have used a lot of image processing technique actually. Means you require a pre-processing, then technique like a removal of noise from data, then extracting the blob, extracting the moving blobs, then classifying that blob. Only we use the yellow algorithm for classification purpose. Yellow was used, yellow V8 version.
So your promise nobility is just implementing that
No, no,
reprocessing
for
technique.
no, not pre-processing technique. Yellow we had to use, but some applications we have introduced our own layers actually into the model. You have to introduce like just wait. Do you have any particular question on particular slide?
And actually, I want to know what are the models available for this one detection? YOLO is one of the standardized model which is available.
Hi, yellow is a very standardized model. We have developed actually our own model actually. My students has developed. Are you faculty?
Yes, sir.
So why don't you write a mail to me? I can discuss
Okay,
actually.
yes,
Okay.
sir. Sure, sir. Please share your
Uh,
mail ID in the chat box. I will discuss with you.
hi,
Hi,
you
sir.
can.
Am I audible, sir?
Hi, yes, yes.
Yes. Very good afternoon, sir. I'm Dr. Vishal from Ajinkya by Patel University, School of Engineering. So
Okay.
I just want to ask one question to you, sir. That what kind of the pre-processing is essential by performing the vehicle classification? So this is my
Ah,
first question, and second is what about that? Can you suggest some kind of the packages to perform the deep learning on this, the vehicle classification or vehicle identification topic?
okay. No, no. First thing, pre-processing, we did a lot of. Actually, first thing, at gate number one, whatever video we have placed, I presented the result. So there, actually, we have collected the data in the early morning time, evening time, daytime. So the sunlight is different actually. Okay.
Okay.
Sometimes during evening time, there's a backlight kind of problem. Means objects are looking dark actually.
Okay.
Means a car, or even car or bus, both are looking like only blackish. Maybe at 6 p.m. or 7 p.m.
Okay.
So at that time we want to increase the brightness. Means, so it is called as a backlight removal problem. So there are techniques like a backlight removal problem.
Mhm.
Morning time, if there is a fog, then fog removal kind of problem you can handle. So all these are different pre-processing techniques, and you can work on them differently. You have to apply different techniques for even during rainy season. Actually, you will get a different type of videos. This,
Okay.
so there also you have to use some special algorithm.
Yes, sir, sure, sir. And what about the sir, deep learning and which type will comes under the perform the classification?
Which
Which type will come there? Means there are three types now. So which I can use for to classify the vehicle classification?
no, no, you say again which three classes?
No, sir. Actually, my question is in deep learning there are three types now for the to perform the classification. That
Uh,
ANN, CNN, and then RNN. So which kind of which one I can use to perform the vehicle classification?
no, no, these are such some initial algorithms, CNN, RNN actually,
Mm-hmm.
but there are so many models are available, like VGG16, Inception, then mobile net. There are many versions. Okay.
Okay.
Uh, so CNN model, whatever I have not discussed that also in detail, but CNN model people use for some elementary level, means feature extraction purpose.
Okay.
So you should go for some higher level models, VGG16,
Okay.
Inception, all
Mm-hmm.
those models you have to use.
Okay. Fine,
And
sir.
it's not only question of using the model also
Mhm.
for classification purpose. Nowadays, there is a lot of development. People are using the auto encoder kind of thing also. Means encoder part, you have to use one model.
Okay.
Okay. Then decoder part, you have to use another model.
Mm-hmm.
And in between, there will be error actually.
Okay. Okay. Fine,
So,
sir.
so there are so many models. Okay.
Okay, sir. Yes, sir. Sure, sir.
So
Thank you, sir.
you go through it. Actually, you will come to know. Another is a uh, GAN model is also there. Means
Okay.
adversarial network. It is called as a generative adversarial network.
Okay.
So there are so many models. You cannot say that we should use this model. You start with any model actually, simple model,
Yeah.
and then keep on working. You will come to know the problems or accuracy. If accuracy is very poor, then you change model or you modify that model by introducing number of layers. So many things are a little arbitrary in the deep learning approaches. Okay, that you have to keep in mind.
Yes, sir.
It's
Sure, sir. Sure. Thank you, sir.
it's it's not like not a straightforward like a machine learning. Okay,
Okay, sir. Sure, sir. Thank you, sir.
okay, yeah, yeah. So I'm going to share my mail ID and phone number also. So anybody can talk me. I would like to discuss your problem, okay, and
Yeah, sir. Sure,
suggest.
sure, sure. It will be a great help to us, sir. Thank you, sir.
Yeah, okay.
Okay, you unmuted. Okay, thank you so much everyone for your valuable questions, and especially I thank the resource person for showing us all the live implementation, and it was very inspiring. Sir, I request you to have some internship program for our students so that we can send them to your institute, so that you can mentor.
Yeah. No, why not actually? In fact, every even December also I conduct internship
Okay.
program.
Yeah.
So you ask your students to contact me, okay? Then I will send a form actually. Officially, we can invite them, okay?
Surely, sir. So due to paucity of time, we have to stop from here because the next session is going to start in 5 minutes. So I thank you so much
Right.
for your valuable time, and we will definitely invite you again in the future. Thank you so much.
Okay. Thank you.
Thank you, sir. Thank you so much.
Thank you. Bye. Thank you.
Next,